Okay, arithmetic sequences. Of course, we've got to start off, like we do every lesson, with some vocabulary. You'll need to know basically what is an arithmetic sequence. It is a sequence in which the difference between any two consecutive terms is the same. In that definition alone, you're probably wondering about a couple other words. There's a vocabulary word, difference. You know what different means. It means to subtract, the answer to a subtraction problem. Consecutive. What does consecutive mean? It basically means one right after the other. We're not skipping around. Like, here's an example of an arithmetic sequence. 3, 6, 9, 12, 15. The consecutive terms are 1 and 3. That's the first term and the second term. That's consecutive. We're not looking at the first term, then going to the fifth term, or the third term, and then going to the first, back to the first. We are looking at this sequence in order. Okay, the difference between any two consecutive terms. So if 3 and 6 is my consecutive terms, and I want to find the difference between those two, 6 minus 3 is 3. My second and third, 9 minus 6 is 3. 12 minus 9 is 3. 15 minus 12 is 3. Here's an example of another arithmetic sequence. 2, 7, 12, 17, 22. Okay. Common difference. That's what we were just talking about. It is the difference between any two consecutive terms in an arithmetic sequence. Using the same examples we used earlier. 3, 6, 9, 12, 15. The common difference is 3. Or 2, 7, 12, 17, 22. The common difference is 5. Okay. Term. What is a term? It is basically a number in a sequence. Any of these numbers are considered a term. The 3, 6, 9, 12, 15. 3 is your first term. 6 is your second term. 9 is your third. 12 is your, and so on and so on. N. For arithmetic sequences, n is our most common variable used to represent a position, which is basically what we were just talking about. The nth position could be in the 15th. It could mean the 20th term. It could mean the 250th term, but we just try to stick to the first 5 terms, 1, 2, 3, 4, 5, and then of course beyond 5 it can become n to represent a term way down the line. Algebraic expression. It could also be called a rule. It is a combination of variables, numbers, and it has at least one operation. Here are some examples of expressions that you might see. 3n minus 1, 5n plus 2. Both of these have two operations, multiply and subtract, and then you've got multiply and add. But they do not have to have two operations. It only has to have one. Okay, so there's the vocabulary that you're going to need for this lesson. All right, what is the best strategy to solve for a sequence? Well, I am going to recommend that you solve, or actually I'm going to require that you set up an H chart every time. There are 2 different ways you can solve it. You can find the sequence that you get from a rule. So an H chart has got 3 columns. The very first column is always your position, and we've talked about what your positions are: your first term, second term, third term, fifth term. This will always be the case. Your first column is always 1, 2, 3, 4, 5. It can go beyond 5, obviously, but we only, for our purposes, we need at least 1 through 5. The middle column is your rule or expression. It's basically a process, how we get from this position to the value of our term. Now, we are given the rule in this case, so it's 3 times n, and then we subtract 1. Well, if our n is our position, 3 times 1, we're going to substitute, every time we see an n, we're going to substitute it with 1, and then solve. Substitute with 2, and then solve. Substitute with 3, and then solve. Substitute with 4, solve. Substitute with 5, and then solve. So, since n represents our position, we have to substitute our positions in where you see, and then we solve to get a value, and a value for the first term, a value for the second, third, fourth, and fifth, and that creates our sequence. So using this expression or rule, we get the sequence 2, 5, 8, 11, 14. And this would be our answer, is our sequence. So that is the first way you can solve a sequence. They give you the expression and you solve for the sequence. The other way is that they give you the sequence and you have to solve for the rule or the expression. Again, I'm going to ask that you set up an H chart. It works every time. It's so much easier to see how we get from the first column over to the third column. So pretend like this column isn't there. We've got position 1, 2, 3, 4, 5, and then n because it can be any position. And then we've got our value, 7, 12, 17, 22, 27. Well, use your common difference to your advantage. We find that the common difference between these terms is 5. Well, since we know that our terms are changing by 5, we know that we are multiplying n times 5. So whenever you find your common difference, you should immediately think 5n. Or up here, it was 3n. I mean, it can be any difference, but once you find that difference, it starts your rule, your expression. 5, 5, 5, you notice this. 1, 2, 3, 4, 5. Since we're multiplying it times n, you substitute position. Well, if I look up here at this first value, 5n, 5 times 1 is 5. But if my first term is 7, what do I have to do to get it to 7? I had to add 2. And remember, whatever rule you choose, it has to work all the way down. This is our process of getting the first column to make this value. Let's make sure that it works all the way down. 5 times 1 is 5, plus 2 is 7. 5 times 2 is 10, plus 2 is 12. 5 times 3 is 15, plus 2 is 17. 5 times 4 is 20, plus 2 is 22. And 5 times 5 is 25, plus 2 is 27. So this part right here, the add 2, that is what do you have to do to get from the 5n to your first value. Since it was 7, we had to add 2 to get from the common difference to that first value. That is always going to be the second part of your expression. Okay? The common difference is always multiplied by n. It's basically what starts your rule or your expression. Common difference starts your expression. Okay. In summary, when solving an arithmetic sequence question, always set up the H chart. I will require you to do this every time. The position column is always 1 through 5. It can be more, but 1 through 5 is pretty much a good start. You will be given either the rule to solve for the sequence, or you will be given the sequence to solve for the rule.